What up, dogs? It's time for the semester one final exam review video. Back by popular demand, right? These things are blowing up on the YouTubes these days, so let's get after it. Let's do it. All right. So we're gonna start with some stuff from our first unit here. See if we can recall some really fun stuff. Okay. So let's start with this. Actually, we'll say graph using. So this right here is in standard form. Graph using the x and y intercepts. All right, so how do we do that? Well, if I want to get my x-intercept, I need to plug in 0 for y. So I'd have 6x plus 4 times 0 equals 12, or in other words, 6x equals 12, so x equals 2. So my x-intercept is 2 comma 0. And I can do the same thing for my y-intercepts, or my y-intercept, excuse me, I shouldn't pluralize that. I'd have 6 times 0 plus 4y equals 12, and then we'd come down here and we'd get 0 comma 3. So those are my x and y intercepts. I could just ask you what are the x and y intercepts in this problem, or I could ask you to also graph it. So let's go ahead and graph these. So I'd have, it was 2, 0. There's my x-intercept, 0, 3, 1, 2, 3. There's my y-intercept. Connect the dots, done. All right, on a multiple choice exam, which is what we have, you'd end up having to match the graph with the given equation. We could ask for x and y intercepts, just some things like that. All right, next one. Let's solve for x. Absolute values. What the heck? These are some of my favorite types of problems because you kind of like get double the math out of it. You know what I'm saying? All right, so we got 3x minus 1 equals, and I'm going to subtract 5 to get 11. And now I have 3x minus 1 equals 11, and 3x minus 1 equals negative 11, okay? Whatever's inside the absolute value is going to turn positive, right? So if I had 11 in the absolute value, I get 11. If I had negative 11 inside the absolute value, if I get 3x minus 1 to equal that, I get positive 11. So I set up both scenarios here. I'm going to get that look more like a 3. And now I have 3x equals 12, so x equals 4. And over here, I'm going to have 3x equals negative 10, so x equals negative 10 thirds. Usually one of them ends up being a fraction. Sometimes they both work out really nice. I need both answers. Big thing here, you need to move that guy to the other side first, then set up your 2. Otherwise, science can get messed up and things like that. All right? All right, next one. We got write the equation of the transformed parent function, or write the equation of the function I had a tough time wording this one, all right? If it is shifted up 7 and left 4. So we're taking a quadratic and we're going to shift it up 7 and we're going to shift it left 4. I apologize for the wording. Try and do this quickly on the fly here for you. So let's say this is going to be our g of x function. It's going to be the one that's transformed. If I'm going up 7, that's adding 7 on the outside, and left 4 is adding 4, x plus 4 on the inside of the function. So we'd end up having that. Okay, so we could ask you to do that, match one of the equations of your 5 choices, or perhaps we give you the equation and you state what happened here. It went left 4 and up 7, right? Different ways to go about that, especially on a multiple choice test. All right, next one, solve the inequality, and we're going to graph it on a number line. All right, so first things first, I'm going to have to go ahead and distribute. So I'll have 8x minus 2 minus 10x minus 30 is less than or equal to 10. Combine my like terms, I get negative 2x minus 32 is less than or equal to 10. So negative 2x is less than or equal to, add 32, I get 42. And now I'm going to divide by negative 2. When you divide by a negative, or multiply by a negative for that matter, what do we have to do with our inequality? It needs to flip around. Then we get negative 21. So that would be my answer here, but I also need to graph it on a number line. So I'll make one real quick. Let's say that's 0. Let's say this is negative 21. Now it's greater than or equal to, so that's going to be a solid dot on 21. And it's going to go that away. So you might see it drawn like that. You might see it like shaded in or whatever. So if we ask you to solve something like this, you'll have to match the graph and all that good stuff too. Cool. All right, now we're going to graph the system of inequalities. So there's shading involved in this one, right? I'm going to get some different colors here, little darker colors that'll show up. So we'll do the top one first. So I'm going to start down at negative 3, and I'm going to go up 2 over 1. Up 2 over 1, up 2 over 1. Now, is this going to be a solid or a dashed line here? Well, it's equal to, so it is going to be a solid line. So, oh, nope, there it is. Okay. There's my solid line. And I'm going to be shading above that solid line. All that gets shaded. Cool. I like it. Next, I'll do this one in, say, a darker blue we'll go with. All right, so I'm going to start up at 5. 1, 2, 3, 4, 5. And I'm going down 1 over 3. Down 1 over 3. There we go. Get my ruler out, and this time it is less than, so I'm going to be shading below. But hold up, it's not equal to. So this one I need to dash. There we go. And I'm shading below. So where is that all going to get shaded here? Where it's overlapped, right? So I'm going to just reshade for both of these all at once. It's all going to be in just this area right here where they both overlapped, okay? So either we can give you a system and have 4 graphs that you match to, or vice versa on a multiple choice test. So kind of think about those things as you're studying how this can look multiple choice rather than free response. All right, let's do a couple exponent problems here. We love exponents. They're fantastic. So first one, we're going to simplify. Remember, no negative exponents. Combine everything you can. So we're going to go ahead and start that one. I like to simplify inside first. So I'm going to have, let's see here, it becomes 1 over 4. So 4 here. X, and then x to the 4th. We're going to have x cubed, right? 1, I think that is 1. Minus 4 is negative 3. Pop it in the denominator. 2 minus 1 is 1. So it's going to be y to the 1st up here. And then 1 minus 7 is negative 6, so z to the 6th down here, all to the negative 2nd. Now I'm going to deal with that negative exponent. I'm going to flip this whole thing over. I don't know why I did that. I'm going to flip this whole thing over, and we're going to get, let's see here, 4x cubed z to the 6th over y squared. Now I can distribute that exponent of 2 in there. So 4 squared is 16, not 4 times 2. The exponents are the ones that get multiplied. 3 times 2 is 6. 2 times 6 is 12. All over 1 times 2 is 2. That is my final answer there. Wonderful. Let's do the next one, shall we? I think we shall. I love it. I think I'm going to do a third one after this, just because I'm feeling crazy like that. All right. So let's see here. A couple strategies. One that I really liked that I saw in class was this. We went with x, y squared, and just threw this guy in the denominator right away. That changes that to a positive 4. I don't want that to look like a 9. I don't even know what negative 3 to the 9th is. All right, so I like that. Positive exponents now. Now we can go ahead and distribute it. So I'm going to have x squared, y squared over, and then I'm going to have negative 3 to the 4th power. That's going to become a positive number because it's to an even degree exponent, right? Even degree. So I'm going to have 81. And then x to the, well, 4 times 4 is 16. Y to the 4th. Okay? Awesome. Now I can use my exponent properties. I'm going to have 2 minus 16. Let's see here. Hold up. I got 81. 2 minus 16 is negative 14, so that's x to the 14th down here. 2 minus 4 is negative 2, so y to the 2nd here. And don't forget, got to pop a 1 up there. Okay. I like it. Some people forget that, and they just think, oh, it's just that without anything in the numerator. That's all in the denominator. It's got to be shown. All right, let's do one more exponent problem. Oh, boy, what do we have here? This looks terrible. All right, so I have all positive exponents, right? All x's here. So everything's going to come together at some point. But I got all these negatives inside these parentheses. Okay, so we got to be real, real careful here. So negative x to the third to the third. The third to the third becomes to the 9th, right? But this you can think of almost for all of these, not almost, you can think of these all as negative 1s. And I would suggest it. Negative 1 to the 3rd power is negative 1 times negative 1 times negative 1, which is negative 1. So I'm going to have negative x to the 9th, okay, for the first one. Then this next one, negative 1 to the 4th becomes positive 1, so it looks like it just like goes away, and it becomes x to the 8th. Down here, negative 1 to the 7th, that's an odd power, it's going to remain negative, and I get x to the 14th. And now I can put some things together. I have negative x to the 17th over negative x to the 14th. That's going to become positive x to the 3rd. Okay? Be very, very careful with those. Parentheses are a big player there in that problem as to how it all works. And our odd degree exponents retains the sign. The even degree always makes it positive. All right, solve by completing the square. Woo-hoo-hoo. It's been a while, and it's going to take a little refreshing. That's for sure. So let's get down to it. First thing, I got to get x's on one side. Everything else goes on the other. So I'm going to have 2x squared plus 12x, leave a blank, equals -5. Okay, I subtracted 7. And we got another blank there. But before I can do this whole like divide by 2 square thing, what do we have to do first? I need to take out a GCF. I cannot have a lead coefficient there. Whatever it is, I have to take it out, even if that causes a fraction in here. Thankfully, this time it does not. Boom, -5, boom. All right, now we're in business. I need to figure out what to add to both sides. So what I'm going to do here is I'm going to do a little side work, right? A little side work over here. I'm going to take this b value here, which is 6 divided by 2, and I'm going to square that. That's going to be 3 squared, which is 9. And I like to write all that out because it helps me when I'm doing the factoring later on. Okay, so 9 is what goes here. Now, what do I add to the right-hand side? It's not 9. It's 2 times 9, because what I'm really adding is also taking into account that 2 that I took out. 2 times 9 is 18, so I'm adding 18. Cool? All right. Let's keep moving. Let's keep grooving, shall we? Okay. Now, I have 2 and then parentheses x. Well, this is going to factor, and this is why I like this, is because, well, with this one, what multiplies to 9 and adds to 6 isn't too difficult to figure out. But if that was a fraction, it's like, whoa, terrible. Hard to find out. All right, so that's going to be 13 over here. So I have 2 parentheses, the quantity, parentheses x plus 3, close them, squared, equals 13. Now I need to solve for x. So I'm going to divide by 2. And I get x plus 3 squared equals 13 over 2. Now I can square root to solve on both sides. Not to solve. Square root on both sides to get rid of the exponent of 2. So I'm going to have plus or minus the square root of 13 over 2. So I need to rationalize this. And if you remember what that means I'm going to be multiplying by root 2 over root 2 because there's a square root of 2 in the denominator. Not cool in the math world for whatever reason. So I have plus or minus 13 times 2 is 26 over 2. Last step, subtract 3. I'm going to do -3 plus or minus square root of 26 over 2. There it is. Final answer. Boom. Now you might be wondering, like, well, could I just, if it's multiple choice, couldn't I just solve that using quadratic formula? That seems better. And yeah, absolutely. If it just asks you to solve, you might need to do that. So let's think about like things we can ask to like force you to do completing the square rather than just saying it. I could ask you a couple things. I could show some work and I could say like, hey, what's this value going to be? What's this value going to be? What's this value right here going to be, right? I can ask those things which are parts of completing the square, which would force you to know how to do those step-by-step things, right? I went through the whole process. Those are the types of things that we can ask you to force you to do that using completing the square. Okay, awesome, awesome. All right, let's do some more quadratics, shall we? I got one. All right, here we go. Big old loaded question here. What is the vertex, axis of symmetry, y-intercept, and x-intercept of this quadratic equation? There's at least 4 questions. There's 4 questions I could ask here in a multiple choice problem, right? So let's get after it. Cool. Big amount of stuff. Lots of things. I don't know what I'm saying. All right, cool. Vertex, axis of symmetry. It's going to start with x equals the opposite of b over 2a, right? That's my axis of symmetry, which gets me my x-coordinate of the vertex. Well, that would be opposite of b minus or -4 over 2 times 2. So that would be x equals -1. That is my axis of symmetry. AOS. Woo! Now to get my vertex. Vertex. All right. Let's see here. That'd be -1. And then I need to plug that in to get my y coordinate. So let's do that. I'll do that right below. 2 parentheses -1 squared plus 4 parentheses -1 plus 15. So that's +1. So it's 2 minus 4 plus 15. That's 11 plus 2 is 13. All right. -1 comma 13. Cool. And then lastly, or not lastly, my y-intercept. That one's not too bad, right? If I plug 0 in, they cancel, and I'm left with 0 comma 15. It's that last guy right there. That's awesome. Got our vertex, axis of symmetry, and our y-intercept. Now it's time for the x-intercepts, which generally are the biggest pain. First thing, let's try to factor this, right? Because that's always our go-to option. Rainbow method, 2 times 15 is 30. Anything multiplied to 30 and add to 4? Looks like we're in this situation, folks. Doesn't factor after 12 attempts. Cries in quadratic formula. Okay. Quadratic formula it is. Yep, I think so. All righty. So let's see here. We have the opposite of b. So x equals, I'm going to go different colors so it doesn't get lost. X equals the opposite of b plus or minus the square root of 4 squared minus 4 times a times c all over 2a. So 2 times 2. All right, so I get negative 4 plus or minus the square root of, that's going to be 16 minus is that, let's see here, that's 30 times 4 is 120 all over 4. So I'm going to get negative 4 plus or minus the square root of, that's negative 104 all over 4. Now I need to do some stuff with imaginary numbers, right? It's a negative inside the square root. And graphically that makes sense because it was opening up and that vertex was negative 113, so it's way above the x-axis, so it's never going to cross it, right? So I'm going to have, let's see here, negative 4 plus or minus I. Let's actually break this down as well. So that's 2 and 52, 2 and 26, 2 and 13. So I got a pair of 2s, so it'll actually be 2i. Let's make that not look terrible. 2i root, and then 13 and 2 goes back together to become 26. All over 4. And now I can simplify this. Everything's divisible by 2 outside of the radical. That 26 does not come into play here. Negative 2 plus or minus I root 26 over 2. That would be acceptable. You could also have it written separately where it would be negative 1 plus or minus root 26 over 2i if you're writing in the a plus bi form properly. Either one of these would be okay. You should be able to recognize either one as a solution. And there we go. So 4 big things there, right? A lot of stuff there from quadratics. Write the quadratic equation in standard form with the zeros at 1 and negative 5. Well, if the zeros are at 1 and negative 5, that means we're going to have x minus 1 as a factor and x plus 5 as a factor. That's factored form. Had it asked for factored form, I'm done. But it asked for standard form. I got to multiply this bad boy out. It's going to be x squared, and then I have plus 5x minus x minus 5. So y equals x squared plus 4x minus 5. Dope. Gucci swag or something. I don't know. Let's see how for the next one. Maybe we'll do a little bit let's see how we can do some graphing. All right? So I think graphing is always a little weird for multiple choice. All right. We're going to match the equation to the graph, okay? Or it could go vice versa. I can give you a graph, pick the equation. So let's see here. First off, this is a negative quadratic, right? It's in vertex form. It's a negative quadratic, so that immediately takes out that one right there because it's a positive quadratic. And we're down to the other ones. This moves to the left 2. So if we're moving to the left 2, that actually takes out the yellow one over here. And then we're going down 7 rather than up 7. So it looks like it is this one right here. Boom, there we go. Graphing in a multiple choice setting. Quick check back here. What is my, what's my vertex here for this one? Okay, just for a little bit of more review, right? I could ask you, what's the vertex given an equation? This would be negative 2. Negative 7 is my vertex. What is my axis of symmetry for this one? That would be x equals negative 2. Which way does this open? Opens down. How about this? Does it have a max or a min? Max or min? Question mark. This one has a max, okay? All good questions to ask about quadratics given various equations, different forms, things like that. How about a couple things with imaginary numbers, shall we? So directions might be like, which of the following is equivalent to this? So let's go for it. First one here, you gotta write it out like this. Or at least in your head, be doing that, okay? I can't distribute a square or an exponent into a binomial. So I got to FOIL this out. So we get 2 times 2 is 4 plus 12i plus 12i plus 36i squared. What do I know about I squared? That becomes negative 36, right? It's negative 1. So now I can combine some like terms and be done with it. Negative 36 and 4 is negative 32 plus 24i, and I'm done. Over here, let's see here. That's going to be 3i root 20 plus 4i. This breaks down into, let's see here, 2 and 10, 2 and 5 for those of you that like doing the full factor tree pair. So we get 6i root 5 plus 4i. Can I do anything else? No, that's it. I have 4i's just chilling, hanging out awkwardly at the party, I guess. You know, the math party. All right, how many solutions does the quadratic equation have? So let's take a look here. What the heck does that even mean? Do I have to solve this? No. You can use the discriminant. So quick review of the discriminant. This is something that a lot of us struggle with because you're like wanting to do more math than you need to. So b squared minus 4ac, that is my discriminant. If that is greater than 0, 2 reals. If b squared minus 4ac is equal to 0, 1 real. And if b squared minus 4ac is less than 0, 2 complex, 2 imaginary, or no real solutions would be an option depending on how it's worded. Okay, so let's go ahead and calculate this. B squared would be 5 squared minus 4 times a, which is 1, times negative 10. So I'm going to have 25, and it looks like we're going to have plus 40. So without even finishing this out, I know it's positive, right? So it's going to be 2 reals, but my discriminant is 65, so 2 real solutions. The answer to this one is 2 real solutions. How many solutions does it have? And it will ask you to specify real or complex. 65 is my discriminant. It could also ask, what is the discriminant? And what does it tell you? Okay? All right, solve the inequality. Oh, if you didn't love quadratics, factoring, solving, you're going to love this because it involves inequalities too. Woo! Cool, let's go. All right, so what multiplies to negative 14 and adds to 5? X plus 7 and x minus 2 would do that trick, right? 7 and negative 2 gives me negative 14. 7 plus negative 2 gives me that positive 5. I love it. I love it. We got to keep moving, though, because I want to go do some stuff. It's Saturday right now, and I'm making math videos. What am I doing? All right. I care that much, okay? I want you to do well in finals, so study hard. Study hard, okay? And it'll pay off. All right. So I'm going to get x equals negative 7 and x equals positive 2, right? Okay, so what do we do with that? Those are my values where it's going to equal 0. I need to know when it's greater than or equal to 0. So I'm going to throw down a number line here. We're going to do a little sign chart action. That's the way I like to do it. I don't know if every teacher does that, but I'm the one making this video, so I'm going to do it how I want to. All right, what is a number that is less than negative 7? That's going to tell me what's going on over here, okay? How about negative 8? If I plug negative 8 in to this one, I get a negative number, and over to this one, I get a negative number. A negative times a negative is positive. If I plug in 0, which is between these two, I'm going to get a positive here and a negative here, which is negative. And if I plug in, say, 3 over here, which is a number that's greater than 2, positive times positive is positive. Okay. So now I know where it's positive, where it's negative, and I can write my inequality here. X needs to be less than or equal to negative 7, and x needs to be greater than or equal to positive 2. Okay? That'd be an or statement. That would be my full solution. If they had it graphed on a number line, it would look like this. Solid going this way, solid going that way. Right? So if you had to match a graph, cool. If you had to just figure out your inequality, the one that's circled is your answer. Now, what about graphing it where it's like y is less than or equal to, y is greater than or equal to, and we have a quadratic? Let's do that. All righty, so let's graph this quadratic inequality, shall we? If I'm going to graph that, I'm going to need my vertex. So I need my axis of symmetry. So opposite of b all over 2 times a. That is going to be positive 1. Yes, I am picking some easier numbers to work with here. All right, so if I get 1, my vertex is then 1 comma something. And let's see here. I would have 1 squared is 1, make that negative. So negative 1 plus 2 is positive 1. Minus 1 is 0. So I get 0. 1, 0 is my vertex. Cool. All right, so let's go ahead and plot that, shall we? Hey, I know what. I've got think I got a graph ready to rock here. There it is. Oh, nope, that's the quadratic one. Hold on 1 sec. All right, here we go. So I've got 1, 0. Why does I thought I just selected green. I want dark green here. Okay, 1, 0. Cool. And then let's see here. If I plug in some other points, I would get, if I plugged in 2, I'd end up getting 1. If I, actually, no, I'd end up getting -1. I also know that my y-intercept here is -1, so that's cool. That's 3 points. And if I were to plug in, say, 3, I'd end up right down here, and same with this one over here. So if you want to do a T-chart, cool. The main thing on this one here is I'm trying to show you how to graph it, and then there's shading involved. All right, so is this solid or dashed? It's equal to, so that's going to be a solid line, or curve rather. Okay, now it's greater than, so it's going to be above the vertex, which is all outside here. Had it been less than or equal to, it would have been below, which would land inside the parabola, if you will. Okay, if you will. All right, that was fun. I think that's almost about it for quadratics. 1 sec. All right, describe the transformations from the parent function f of x equals x squared, where we have g of x equals -3, parentheses x plus 1 squared minus 5. So what the heck's going on here? Well, first off, let's go with this. That right there is a reflection, right? A vertical reflection. All right, next one. That right there is a vertical stretch by 3. Let's see here. Keep moving. There we got. We're going left 1, and I've run out of colors, so we'll go with, hold up, how about orange? That's going to be down 5. Cool. I like it. All right. Wonderful. Cool. What else can we ask here? How about this? Let's do another one of these. How about, does it have a min or max? This one, it's negative again, so it's opening down like this. So this one's going to have a maximum on this one. What else could we ask? What's the vertex? This would be -1, -5 for my vertex. Okay, all good things. I think that's pretty good for quadratics here. All right, I think what I'm gonna do is I'm gonna cut this video off here. We got a good 2 main chapters that are in this thing right here, and then we're gonna go into some other stuff, the polynomial review, a little bit of functions, and then one other little special treat in the second video. So, you know, hang tight, wait for that second one. I'm gonna have to do that tomorrow because we got to get going. We got plans, okay? I got plans, you know what I'm saying? And we're old people, so our plans start at 5:30, 6 o'clock. You know what I'm saying, right? So, yeah, all right. I think I'm just gonna go do some math, some more math. You know, hang out and you know, America, freedom, rock and roll, Costco, Riverdog, Jenny on the gram, yo ro, America, and you guys have a wonderful night. Enjoy your studying, and I will see you in the second video, the exciting conclusion, the sequel that is totally different, also equally as awesome and good. See ya. I'll stop talking.